A rigid body's kinetic energy is the sum of 1/2 mv squared over all its particles, and each velocity is the translation of the center of mass plus the cross product of the angular velocity with the position vector. Substituting and expanding gives three terms. Because the origin sits at the center of mass, the mass-weighted sum of the position vectors vanishes, so the cross term drops out, and the energy splits into translation plus rotation. Expanding the squared cross product. The rotational part is a quadratic form in the components of the angular velocity, and the whole mass distribution collapses into 9 coefficients, the inertia tensor. Every component is a sum over the particles. The 3 diagonal ones are the moments of inertia about the axis, mass times squared perpendicular distance, while the off-diagonal ones are minus the mass times a product of 2 coordinates. These 9 numbers are not intrinsic to the body. They depend on where we point the axis. Turn the axis around and the diagonal values change, while the off-diagonal components grow and shrink. Because the tensor is symmetric, some orientation always makes every off-diagonal component vanish at once. Those directions are the principal axis, the 3 numbers left are the principal moments, and the rotational energy becomes a sum of 3 squares. The 3 principal moments classify the body. All different is an asymmetrical top. 2 equal is a symmetrical top, whose perpendicular pair of axes may be chosen freely. All 3 equal is a spherical top. 2 special cases. If the particles all lie in one plane, the principal moment about the perpendicular axis equals the sum of the other 2. If they lie on a straight line, the third moment is 0, and the rotator has only 2 rotational degrees of freedom. Finally, the formulas above need the origin at the center of mass. Yet another origin is often easier to compute with. The 2 tensors differ only by a correction built from the total mass and the displacement.